Our project is about decentralized energy exchange platform. In this video, I'll be showing you how the real-time market price evaluation works, which we have built using Dart. And then in later half of this video, I'll show you a demo on the peer-to-peer energy exchange platform. Before that, let's have a look at the high-level overview of the architecture. On the left, we have a public network where all the prosumers are connected to our platform. All the prosumers will be publishing their real-time energy metrics, energy export metrics, and the export prices through MQTT on a specific topic allocated to each of the prosumer. On the right, we have the EMQX MQTT broker or the server, which facilitates the exchange of MQTT messages with the publishers and the subscribers. Then we have the Telegraph, which is a data aggregator that collects all the real-time metrics from the prosumers topics and ingests it into the InfluxDB time series database. In parallel to this, we have the real-time market price evaluation server written in Dart that connects to MQTT and listens to the net export energy and the export prices of all the prosumers and updates the market price in real time. Then we have the proxy trader, which creates buy or sell orders to the exchange on behalf of the prosumers. Finally, we have the peer-to-peer trades exchange and transactions API server, which manages all the list of all registered prosumers, receives the buy or sell orders, and finally processes the orders to create trade records. This API server is built using Django REST Framework. Now let's jump on to the first part of the demo, where we'll demonstrate the working of the real-time market price evaluation server. We are using Docker Compose to run all of the required services, including the mock prosumers that will perform the mock publish of the metrics of the prosumer. This is the Scramjet service, which is the market price evaluation server. And here is the EMQX MQTT broker as a service. We already have the Scramjet server, market price evaluation server running. Now let's go ahead and launch the mock prosumers. As you can see, the metrics have been published and the market price evaluation server has reported the latest market price. For example, let's take the 8th prosumer. The export power is -1000. The base trade price was set to 5.687. It's not an external prosumer. And the trade price finalized was 5.97. Now, how exactly the market price evaluated is a long algorithm. The algorithm is built such that it performs fair adjustments to account for the limit pricing model of external prosumers, transmission losses, and other cash losses that are bound to happen. The primary objective of the algorithm is to maintain balance between the cash inflow and cash outflow. In-depth details of the algorithm can be viewed from the report. Now, let's just stop this and jump into showing the peer-to-peer exchange platform. First, let's go to the DEX platform and onboard ourselves by creating a new account. Now that the billing account has been created, we can see that we have by default landed on the prosumers page and we do not have any prosumer. So let's just go ahead and register a new prosumer. Let's just give some random latitude, longitude values and hit register. We can see that the prosumer has been registered. Now I have fast forwarded and registered 3 more additional prosumers. Now if we go to the orders tabs, we can see that we do not have any orders so far. So let's just go ahead and create some buy or sell orders for these prosumers. Ideally, the smart meter or the prosumer smart meter will be sending in publishing their net export power through MQTT. However, for the sake of demonstration, we will be manually creating those 4 orders on behalf of the 4 prosumers. So let's just select all the prosumers. Now that we have configured all the 4 prosumers orders, let's just go ahead and sell and buy all of them. Now, if you go to the orders tab, we can see that the 4 orders has been created for each of the prosumer, and all of the status is order request received. That means the Exchange server has acknowledged that the order has been received, but it is yet to be processed. Now let's just go ahead and manually trigger the Exchange to process the pending orders queue. We are doing this just so that we don't have to wait for the Exchange until it does it automatically. We can see a notification that says all open orders have been processed. So if you go back to the orders tab, we can see that the status has now changed to be completed. And now if you go to the trades tab, we can see the trade records that have been created. So in the end, we have managed to perform virtual peer-to-peer exchange of energy. And that's all about our decentralized energy exchange project. Thank you.